This video will cover Chapter 25, Paired Samples and Blocks, the Hypothesis Test. We will be working through a problem about resting pulse rates for men. 10 men volunteered to test an exercise device advertised on television by using it 3 times per week for 20 minutes. Their resting pulse rates in beats per minute were measured before the test began, and then again after 6 weeks. The results are shown on the table on the left. And we want to find out if there's evidence that this kind of exercise can reduce resting pulse rates, and by how much. All right, so before we begin this test, we see that we have 2 different samples. But these 2 different samples are very different than our 2 different samples before, because they are not independent of one another. What that means is they are matched by subject. So for each subject, we have 2 different sets of information about them. They're before resting pulse rate and they're after. So since we can no longer assume independence, we're going to have to do a different kind of test. This test is actually a lot easier than the 2 sample t-test, because what we're interested in, especially since we want to know by how much this kind of exercise can reduce resting pulse rates, we really care about the differences between the 2. Okay, so we're going to start by putting our data into our calculator and discuss this a little bit further. So I want you to go to Stat, Edit, and put your data into L1 and L2. You may want to pause to get it into your calculators. Okay, now that you have your data in your calculators, I want you to go up and highlight L3, because we're interested in the differences in the pulse rates. So we're going to take column L1 and subtract L2. So with L3 highlighted, I want you to press second 1 minus second 2 and enter, and that will get us all of our differences. I'm going to enter those differences into my table. You should too. Okay, scroll down. I suppose I could have just subtracted this myself. Okay, all right. So now that we have all of our differences, let's think about what our hypotheses are. These are going to look a little bit different because, again, we only care about this column now. We only care about the differences in their pulse rates. So our null hypothesis is going to be about the average of those differences. Our null is that the mean of those differences, I'm going to write that mu sub d, d for difference, is equal to 0. That means there is no difference between the 2 pulse rates. So this exercise device is really doing nothing. And then the alternative is that the mean difference is greater than 0. Greater than 0 because we did L1 minus L2. Okay, so we are expecting that the second one, L2, is less than L1, so we expect our differences to be positive. Okay, now we're going to address our conditions. Our conditions for this look very much like the conditions for a 1 sample t-test, aside for one. The first condition. This condition is that the data is paired. Okay, so we want to assume that we have data for pulse rates is paired by subject. Okay, so I want to talk a little bit about what it means to be paired by subjects. I'm going to scroll down to the notes section down here. Okay, paired data can come about from an experiment, okay, and that often happens through blocking. If you remember when we learned experiments earlier in the year, we would sometimes block our experiment, which really was like running 2 separate experiments at the same time. And the reason we would block was because we would think that whatever the variable is that we were blocking on was going to add too much variability to our results, and it wasn't going to be as clear what the effects of the treatment was. Okay, so we would block by gender or age or all kinds of things. Okay, so with an experiment we can get paired data, and with an observational study we can also get paired data. And that comes about by matching, which is sort of what we're seeing here. Okay, because this isn't an experiment with a control or whatever, this is an observational study. Okay, so the next 3 are going to look just like the ones we had for 1 sample t-test. Do we have a simple random sample? No, we had 10 volunteers. Okay, so we're going to assume that we have a representative sample of men. This could be a dangerous assumption because these men are volunteering to be a part of this study. Okay, so we're making a big assumption here. All right, and we also need to say that 10 is less than 10% of all men that we're concerned about. Okay, I'm not sure what population we're interested in, but I think we can be pretty sure that 10 is less than 10% of that. And our final one is that our data is approximately normally distributed. So since we have the data, we can check that here. If we do not have the data, remember, we have to assume that, but we can check that with our data. Now, we don't care about the individual before and afters. We only care about the differences. So we only have to make one histogram. So I'm going to go back to my calculator and go to second stat plot. I'm going to turn that plot on, make my histogram, but this time it's going to come from L3, so I'm only looking at my differences. Zoom 9. And there it is. So we're going to copy it onto our papers. Not loving this as far as it being approximately normally distributed. Okay, so data for differences not normal. Proceed with caution. Okay, but we're going to continue ahead with our test anyway. Okay, so we've checked our conditions, we've checked, and we're a little bit concerned, and we've written our hypotheses. So it's okay to use a matched pairs t-test for means. Okay, and all a matched paired t-test for means is a one sample t-test. From now on, it is exactly the same as a one sample t-test. Okay, so let's remember what we do for a one sample t-test. The first thing is that our n is 10, because we have 10 subjects in our group. Each of those subjects had a before and an after pulse rate recorded for them. Okay, and let's get our statistics. Okay, we're going to do one var stat, but for L3, so make sure you tell it to read L3. And our mean difference in this case is 2.8, and our standard deviation for our difference is 2.5. So we're ready to continue by estimating our standard error for our differences. Okay, and we're going to do that, remember, by taking our S for our difference over the square root of n. And so that's going to be, in our calculator, we're going to take 2.5 and divide it by the square root of 10. Okay, and that's 0.79. So we're going to calculate our t-score by taking our mean, 2.8, subtracting 0, and dividing by the standard error. So we're going to take 2.8 divided by 0.79 to get a t-score of 3.54. Okay, so now I'm looking at my normal model. No, not my normal model, sorry, my t-model. My t-model with 9 degrees of freedom, because our degrees of freedom are n minus 1. This is just like a one sample t-test. We're centered at 0, because we assumed the difference was 0, with a standard error of 0.79, and we are comparing our difference of 2.8, and we're doing an upper tail test. So I'm going to go to distribution, TCDF, which is number 5, and I'm going to go from 3.54 standard deviations above the mean to 99, and I have to tell it I'm using 9 degrees of freedom. Just got to think about it, and then it gets me a p-value that is equal to 0.003. Okay, So now it's time to draw our conclusions here. So we have a very low p-value. Okay, so due to a low p-value of 0.003, we reject the null hypothesis. There is significant evidence to indicate that the exercise machine reduces the resting pulse rate. Okay, and if we wanted to do this completely out on our calculator and not use TCDF, we could just go stat tests. And again, this is a one sample t-test, so we're just going to go to t-test, and we're using data. Our data, or our initial mean difference, right, because this is the mean difference, was 0. We're pulling our data out of L3. And we care about our mean difference being greater than 0. And then we would calculate, and hopefully we get the same things. We got a t of 3.5, which is just what we had here, a p-value of 0.003. So we have all of the same values. Okay, so you could always just copy those onto your papers as well. So that concludes the matched pairs t-test.